The science behind controlled release fertilizers, chemical formulation. Title: The science behind controlled release fertilizers, chemical formulation. Introduction. Fertilizers play a crucial role in ensuring optimal plant growth and maximizing crop yield. Over the years, advancements in agricultural science have led to the development of controlled release fertilizers, revolutionizing the way we provide essential nutrients to plants. These fertilizers are designed to gradually release nutrients over an extended period, ensuring sustained nourishment for CRFs. In this article, we explore the science behind controlled release fertilizers, with a specific focus on their chemical formulation. Instead of releasing all the nutrients at once, controlled release fertilizers gradually disperse the nutrients over a specific time frame. This controlled release mechanism provides plants with a more consistent and sustained nutrient supply, reducing the risk of nutrient leaching and optimizing plant uptake. Chemical components of controlled release fertilizers. The chemical formulation of controlled release fertilizers involves several key components that work synergistically to govern nutrient release. Let's explore these components in detail. 1. Base fertilizer. Controlled release fertilizers consist of a base fertilizer, which is typically a blend of essential nutrients like nitrogen, N, phosphorus, P, and potassium, K. The base fertilizer provides the primary source of nutrients required for plant growth. 2. Coating materials. To achieve the controlled release effect, the base fertilizer granules are coated with specific materials. These coating materials regulate the release rate of nutrients by forming a barrier around heat granules. Commonly used coating materials include sulfur, polymers, resin, waxes, and others. 3. Nutrient binding agents. Controlled release fertilizers often incorporate nutrient binding agents, which are responsible for holding the fertilizer components together. These agents prevent the premature release of nutrients by enhancing the structural integrity of the granules. 4. Coating modifiers. Coating modifiers are additives that are included in a formulation to fine-tune the nutrient release characteristics of the controlled release fertilizers. These modifiers can alter the release rate by affecting the solubility or permeability of the coating materials. Various factors, such as temperature, moisture, and soil pH, can influence the release of nutrients. Mechanism of nutrient release. The controlled release mechanism of fertilizers relies on both physical and chemical processes. Upon application, the fertilizers gradually release nutrients through the combined effects of diffusion, abrasion, and microbial activity. 1. Diffusion. Diffusion is the primary physical process involved in nutrient release from controlled release fertilizers. As water penetrates the coating material, nutrients dissolve and diffuse through the coating. Moving towards the soil solution. The rate of diffusion is influenced by factors such as temperature, moisture, and concentration gradient. 2. Abrasion. Abrasion occurs when the coated granules are physically broken down or reduced in size due to environmental factors, such as rain or irrigation. As the granules wear down, more surface area is exposed. Accelerating the release of nutrients. 3. Microbial activity. Microorganisms in the soil play a significant role in nutrient release from controlled release fertilizers. Microbes break down the coating materials and convert the nutrients into forms that are readily available for plant uptake. The rate of microbial activity depends on various soil factors, including moisture, temperature, and the presence of organic matter. Advantages of controlled release fertilizers. Controlled release fertilizers offer several advantages over traditional fertilizers, making them increasingly popular among farmers and gardeners. 1. Nutrient efficiency. By releasing nutrients gradually, these fertilizers ensure that plants have a constant supply of nutrients, reducing wastage and preventing nutrient leaching. This leads to improved nutrient efficiency and reduced environmental impact. 2. Reduced application frequency. Controlled release fertilizers require less frequent application compared to conventional fertilizers. This reduces labor costs and simplifies fertilizer management. 3. Improved crop quality. The sustained nutrient release provided by controlled release fertilizers promotes balanced plant growth and minimizes nutrient deficiencies. This results in improved crop quality, increased yield, and enhanced stress tolerance in plants. Controlled release fertilizers revolutionize the way essential nutrients are provided to plants, ensuring sustained nourishment over an extended period. These fertilizers differ from traditional ones by gradually dispersing nutrients instead of releasing them all at once. The chemical formulation of controlled release fertilizers involves several key components that work together to govern nutrient release. The base fertilizer is a blend of essential nutrients like nitrogen, phosphorus, and potassium, providing the primary source of nutrients for plant growth. To achieve the controlled release effect, base fertilizer granules are coated with specific materials. Coating materials, such as sulfur, polymers, resin, waxes, and others, regulate the release rate of nutrients by forming a barrier the granules. Nutrient-binding agents are incorporated into controlled release fertilizers to hold the fertilizer components together and prevent premature nutrient release. These agents enhance the structural integrity of the granules. Coating modifiers, on the other hand, are additives that fine-tune the nutrient release characteristics of the fertilizers. They can alter the release rate by affecting the solubility or permeability of the coating materials. Factors like temperature, moisture, and soil pH influence the nutrient release. The nutrient release mechanism depends on both physical and chemical processes. Diffusion is the primary physical process involved, where water penetrates the coating material, allowing nutrients to dissolve and diffuse through the coating and move towards the soil solution. Factors like temperature, moisture, and concentration gradient influence the rate of diffusion. Abrasion occurs when the coated granules are physically broken down or reduced in size by environmental factors like rain or irrigation. As the granules wear down, more surface area is exposed, hastening nutrient release. Microorganisms in the soil contribute to nutrient release by breaking down the coating materials and converting nutrients into forms readily available for plant uptake. The rate of microbial activity is influenced by soil factors like moisture, temperature, and the presence of organic matter. Controlled release fertilizers offer several advantages over traditional fertilizers. They provide nutrient efficiency by reducing wastage and preventing nutrient leaching. This leads to improved nutrient efficiency and reduced environmental impact. Additionally, controlled release fertilizers require less frequent application, reducing labor costs and simplifying fertilizer management. Controlled release fertilizers have revolutionized the way essential nutrients are provided to plants, ensuring sustained nourishment over an extended period. These fertilizers differ from traditional L1s by gradually dispersing nutrients instead of releasing them all at once. The chemical formulation of controlled release fertilizers involves several key components that work together to govern nutrient release.